Hello everyone, this is me Arijit with a new video, and in this video we are going to see how we can use Blynk 2.0 for home automation. I think many of you have already used Blynk, but now as we know, like it's been 1 year that Blynk has been updated, and now we have the new Blynk or Blynk 2.0. Now this new Blynk is a little bit advanced compared to the older one, and also I think a little bit complicated to use. So I thought, why not making a video on this? So in this video we are going to build this Wi-Fi extension board. So if you see here, we have 4 sockets in this one, and using Blynk we can control each of them individually. So you can control these sockets using your phone or even using the web dashboard. And I am actually using this kind of wireless extension board in my home, in my aquarium. So let me show you. And as you can see, basically this is the Blynk app here, and I have all different switches, like some are for my lights, some are for the heater, some for the pumps and all that. Just a minute. So as you can see here, so if I just focus into it, and you can see if there is a light on, and if I just turn it off, then the light will be turned off. If I turn it on, the light will be turned on. So this is, yeah, so as you can see. Also here is the second one. This is for the filter or the air pump. So if I turn the air pump off, you will notice that the air pump has been turned off. The air pump is on the left side. And now again, if I just turn this air pump on, then you will notice the air pump has been turned on. So in this way I can actually control all different apparatus in the aquarium. And the main part is I also have a timer option here. So basically some of the devices automatically turn on in a specific time in the day, and they will be turned off in a very specific time. So that feature we are not going to discuss in this video, but also that we'll discuss in some other video for sure. So this is how I am actually using Blynk for quite a long time, and that's why actually I'm making this video, so that you will also learn how you can use Blynk to make this kind of projects. Also, if you're planning to control a very particular device, maybe a fan or light or something like that, and even if you are planning to control maybe a small 5-volt LED or something, a device like that, we are also going to cover all those things in this video. So at the end of this video, you will know how to use Blynk and how to control any device, like turn it on, turn it off using Blynk. So let's get started. So at first we'll do the setup in the Blynk platform. So we'll create the project and do all the setup. Next we'll do the coding, and finally we'll look at the hardware. So you can simply search Blynk in the Google, and you will get the first link will be for the Blynk. So it's blynk.io. And next, if you don't have an account, you can create it, but I'm going to simply log into it. I already have created a project, but for this video I'm going to create a separate project. So whenever you will open, you may get into this template page. So you can simply create a new template. Here you have to give the name. So in my case, I'm going to give it a name Sparklers test. Next, I will choose the hardware. So in our case, it's NodeMCU. So we'll choose ESP8266. If you're using ESP32 or Raspberry Pi, anything else, you can choose that one. The connection type will be Wi-Fi. You can add a description if you want. Next, you click on done. Now we have created a template. Now here you can change any information. So template name, hardware connection type, manufacturer, anything you can change. I'm not going to change anything. Now firmware configuration, here you will see the template ID and template name. If you want, you need to use these configurations in the code. So we have to copy it, but we'll do it later. But you need to use this. The next thing is the metadata. So here, if you want, you can add the device name, owner, location, all those details, but I'm not going to do that. Next, we have the most important thing, that is the data streams. Now, as I say, data stream is a way to structure data that regularly flows in and out from device. Use it for sensor data in telemetry or actuators. So here in this new version of Blynk, if you want to write any data, or if you want to read any data from anything, so from sensors you are reading data, or you are writing any data to anything in any other device, like in our case, we are going to write the data to we are going to make the pins high of the relay. Okay, so here you are writing the data. So in case of sensor, if you're reading some data, so all these things you can do through the data streams. Now here you have the digital data stream, analog, virtual pin, and enumerable and location. Location you cannot use in the free account, but the remaining things you can use. Now digital pins, digital, you already know about digital if you have used the previous Blynk. Also you know about analog and virtual pin, but still I'll say, so I'm going to explain you again. So digital basically means the physical pins. So for example, in NodeMCU, if you see these are the physical pins, so D0, D1, D2. So whenever you are saying that I want to use digital pin 0, that means you are saying that you want to use GPIO 0. So that means D3. This is very important. Digital pin. So here digital pin 0 does not means D0. Digital pin 1 does not means D1. Digital pin 0 means GPIO 0, that means D3. Digital pin 1 means GPIO 1, that means the TX. In this way all this works. Okay, now this diagram you can search for NodeMCU pinout diagram and you will going to get this diagram. Okay, from there you will get all the pin numberings. Okay, even you can go to the Blynk website also. Here also you will get pin numbering. You are also going to get the all the pin numbering. So D1 means 5, D2 means 4, D3 means 0, D4 means 2, all these things. I'll also put this link in the description. So whenever you are writing to digital pins, that means you are literally writing to the physical pins. Okay. What about the analog pin? Analog pins also same. So analog pins basically means you can write analog data and analog, you can read analog data and write analog data. Digital pin means you can either read 01 or you can either write 01. Okay, something like this. What is virtual pin? Virtual pin is basically virtual pin does not refers to any physical pin in the NodeMCU. They are virtual. So you can create any number of virtual pins and you can write any kind of data. So you can write numbers, you can write doubles, you can write strings, whatever you want in the virtual pins. And then you can read the data from the virtual pin in your NodeMCU, and based on that data, you can take decisions. Now digital pin, analog pins are very simple to use, and so if you just define a digital analog pin, you don't need to modify any code in NodeMCU. So I am going to show you how to use virtual pins in this video, because I think using virtual pins you can do most of the things. Okay, so here I'm going to create a virtual pin and I'm going to give it a name like V0, and the pin I'll use V0. Okay, so you can use any pin between V0 to V255. I'm going to use V0 for this one, and the data type will be integer because either I'll write 0 or either I'll write 1. Okay, and then the minimum will be 0, maximum will be 1 unit. So you don't need to select any unit here, you create. Okay, now you have a pin V0, which basically refers to virtual pin 0. Okay, and the data type is integer. Now you just make a copy and give it V1. You create a pin V1, virtual pin V1. Next you create another copy, you give it a name V2, virtual pin 2. You create another copy, you make V4. So we have 4 sockets, so that's why I'm creating 4 different pins. So V3 and all this. Okay, so now we have created 4 virtual pins. Okay, important thing is you remember the pin numbering. So name is not important, the pin number is important. V0, V1, V2, V3, these are the pin names. Data type is important, all must be integer, and the minimum should be 0, maximum should be 1. Okay, this is all about you need to know. Next you can go to events. Now you can create different events in this Blynk, but we are not going to discuss about events in this video. Also we are not going to discuss about automations. We are going to create a web dashboard. It is very simple. You can simply drag and drop the switches and you can easily create a web dashboard. So let me just create 4 switches, and here we have 4 switches. Next you need to do the configuration. For that you go to switch, you go to settings button. Here you give it a name and you select a data stream. So here we have 4 data streams created, or you can also create a data stream for here also. So I'm going to select V0. On value is 1, off value is 0. You can change if you want, and you click save. Now this switch is referring to V0. Similarly, using other data streams, you select the other virtual pins. So V1, V2 and V3. Okay, now we have 4 virtual pins. We have 4 virtual pins here, and next we have the mobile dashboard. Mobile dashboard you cannot create from here. You have to download the Blynk app in your mobile, and then only you can do it. Okay, so you'll do it later. Now web dashboard is complete. Now you click in save, and now you have the 4 switches. You can turn it on, turn it off. Okay, though now it will not do anything because we haven't coded the NodeMCU yet. Okay. Next we'll do the coding. Now to do the coding you need to have Arduino installed. Now I already have installed Arduino. So as you can see, Arduino 1.8.19. Next you need to install the Blynk library. For that you go to sketch, you go to include library, sketch, include library, you go to manage libraries, and here you need to select Blynk. Just a minute, let it get updated. So you need to select Blynk here, to click on Blynk, and you search for Blynk, and you can to click. So this is the one, by this one. Okay, and as you can see, it's already installed. So in your case, you have to select the latest version, you click on install, and it will get installed. Okay, so you only need to have this library only, you don't need any other libraries. Okay, next what you have to do is you have to get the code from my GitHub repo. So you can go to my GitHub repo and just copy the code. I'll give the link in the description. So you copy the code and you come here. Okay, now here one thing is very important. You cannot simply create a new file and paste the code and it will work. Not like that. What you have to do is you have to go to file, you have to go to examples, you have to go to very bottom part here, you will have somewhere Blynk. As you can see Blynk, you have to go Blynk agent, and there you have to go agent ESP8266. If you are using ESP8266, else you can go to 32 or some other thing. You open the file. This is going to be how the file will look like. Now you can modify this file also. Okay, you have to basically define different pins, you have to create the virtual pins, you have to write the functions, all that by add, but I already have did it. So you can simply paste my code here and it's going to work just fine. What you have to do is you have to change this to details. So you can go to your console, you can copy this code, you can come back, you can paste it here, and you are done. Now as you can see what changes we have did here. We have defined the use NodeMCU board. In your case, if you're using something else, then you just comment this line and uncomment the other line, like the Wemos D1 Mini or maybe SparkFun Blynk board, something else. Next, you have to define the pins. I am using pin 16, 5, 4, 10. Now 16, 5, 4, 10 basically means, if you go here, GPIO 16 means D0, GPIO 5 means D1, GPIO 4 means D2, and GPIO, what else I'm using? I just forgot. GPIO 10. So GPIO 10 means we are using GPIO 10 is what? Where is GPIO 10? Okay, GPIO 10 is in this side. This is the this one. Okay, so it's on this side. This is the fourth pin. Okay, so D0, D1, D2, and in the other side the fourth pin we are using. Okay, so it is called SO3. This pin we are using. These 4 pins I'm using. If you want, you can change the pins. But remember one thing, in NodeMCU we are going to make all the pins initially high, these 4 pins. So you cannot use any pin you want. There is a restriction. Okay, because in NodeMCU, if you make some pins high at in the booting time, your NodeMCU will not boot. So if you are using 4 pins for this project, I recommend you use these 4 pins. If you want 8 pins, then I have already noted you can use these 8 pins. So 16, 5, 4, 10, 14, 12, 13, and 3. You can search for 14, 12, 13, and 3 in the diagram, and you will get there. You will get which physical pins I'm referring to. Why I am using these pins? Because these pins I have tested and they work just fine. But there are few pins in the NodeMCU which pins you make high initially and your NodeMCU will not boot. So be careful here. Okay, so you have defined these 4 pins. Next, I have defined a serial monitor so that I can look into the code. Okay, time client, we don't need time client. So I'll modify the code in the GitHub. Okay, so now here we have to define the 4 pins as output, 0, 1, 2, 3. We are defining that these 4 pins we want to use as output. And we have to make these 4 pins initially high. Now I am making initially high because in the relay I am using, in that relay, if you make the pin low, then it's going to turn on the device which we are going to connect with the socket. Okay, we'll talk about that when we'll talk about the hardware. So you make the pin high, it is going to turn off the device. You make the pin low, it's going to turn on the device in my relay. In your relay, if it's opposite, you have to make all the pins low. Okay, and whenever you will get a value, you have to make the pins high. But that you have to test. But in my case, initially all the relay pins will be high, and then whenever we have to turn on a relay, we will make the pin low. Okay, so next we have to create different function for each of the virtual pins. So here I have defined virtual pin 0, blink right V0. So we are going to receive a value in the V0. Okay, so in value equal to as integer, we are receiving a value from V0. If the value is 1, that means we have turned on the switch. You're gonna write low in the pin 0. Why? Because like I said, if I make the relay pin low, it will turn on the relay. Next, if I make the relay pin high and else, so if the value is not 1, so if the value is 0, then you make the pin high. So when I am turning off the switch, it is sending 0, and it is going to make my relay pin is going to like turn off the relay pin. This is about V0. Similar way you have to create V1, V2, V3, V3. So for 4 virtual pins, 4 different function, and inside the function is just going to make the pins high and low based on the input it is going to get from the NodeMCU. One thing very interesting, the advantage of using virtual pins is using a single virtual pin, you can actually make multiple digital pins low. So if you want a feature where maybe using a single button, you want to turn off all the sockets, you can do that. You can define another pin V4, and you can inside that you can write, if the value is 1, you digital write all the pins low. So pin 1, pin 2, pin 3, pin 4, you make all of them low. And then using a single button, you can actually control all the 4 sockets. That thing you cannot do a digital pin. So that is the advantage of virtual pin. You have more advantages. You can just explore those things. Okay, you can just test with the code. And finally, inside the loop, we are going to run the Blynk agent. Okay, Blynk agent.run. Now what if you use any analog pin or in any digital pin? In that case, you don't need to define any of the functions, because if you define a digital pin, Blynk agent will do everything for you. It will make the pin high and low automatically. You don't need to even define the pins. Okay, but again, the limitation will be, it will just make it high and low, and you cannot control using a single button, you cannot control multiple pins. So that is a disadvantage. So that's why I thought using virtual pins in this video. So once you are done with it, you have to connect your NodeMCU with your laptop. So I'm going to connect my NodeMCU with my laptop. Just give me a moment. So I have connected that. Next, you have to go to tools, and here you have to, in the board, you have to go to ESP8266 boards, and there you have to select the NodeMCU 1 module. Okay, now here one thing, if you don't have this ESP8266 board option, you have to download that ESP8266 boards. Okay, so for that you have to go to board manager. And so before go to board manager, if you are for the very first time you are using NodeMCU, what you really need to do is you need to add the you need to go to the file. So for example, you need to go to Arduino, you need to go to preferences, and there additional board manager URLs, you have to put this link. I'll give that link also in the description. So this is the ESP8266 link. You have to put that link here, and you have to click OK. Then you have to go to the tools, you have to go to boards, and you have to go to board manager. And there it will take some time downloading platform index. So give it time, and there you have to write ESP8266. You click enter, you will get it, ESP8266 by 8266 community. You download it. I have already installed it. Then if you go to tools, you are going to get the ESP8266 option. So you go here, ESP8266 boards, and there you will get ESP NodeMCU 1.0, as I am using this one. Remaining things, you don't need to change anything. Everything will be just fine, hopefully. You just need to select the port. In my case, it's USB serial, this one. If you're using Windows, it will be something like COM3 or COM4, something like that. You choose that one. And finally, you need to upload this. So you click on the upload button, and it will get uploaded. Okay, so as you can see, it says done uploading. Next, you go to a serial monitor, and you have to select this particular baud rate, so 115200 baud, and then you will see something like this. So it will first print this. Now so for in your case, it is only going to print up to this one. So init and connecting net. Okay, so it will show all these things like version, flash memory, free memory, all these things, and it is going to print init connecting net. Okay, this is in your case, it will show you this. Now if it is not showing this, then that means there is some problem in the code uploading, or there is something problem. Okay, so you have to fix that. But whenever you will open the serial monitor and you will choose this baud rate, it should show you all these things. Now in my case, why it is showing all these things? Because previously I have uploaded some codes in the NodeMCU with Blynk, and I have configured my Wi-Fi. That's why it is automatically getting connected to my Wi-Fi. But don't worry, I will show you in your case how you can connect this to your Wi-Fi. But before that, we'll set up the hardware. So we'll connect with the relay and the sockets, and then finally we'll install the Android app, and I'll show you the setup there. Okay, now let's talk about the hardwares. So we will talk about all the different components. So at first, which components we need? Now obviously we need a NodeMCU in our case. So here I have the NodeMCU connected with the USB. So we need a NodeMCU. Next we need a relay. Now in my case, I have used a 4-channel relay, but depending on how many sockets you want to connect, you have to use that channel relay. Also you need a 240 volts to 5 volt converter. Now as here in India, the mains are at 240 volts, you need I need a 240 volt to 5 volt, but in your case if it's something 120 110, you need that kind of thing. Okay, also you can use a mobile adapter, because mobile adapters normally convert that mains voltage to 5 volts, so that one also you can use. Now here I am using one of these voltages, so basically it takes 220 volts as input and it gives 5 volts as output. Okay, and using that 5 volts output, we are going to power the NodeMCU and also the relay. This is how it's going to work. Okay. Now if you see here how the connection, so the connection is very simple. So at first let's talk about the relay connection. So most of you already know that in relay, for per relay you have 3 pins. So one will be the not naturally connected and another will be naturally connected. Okay, so at the middle pin we are going to give the 240 or the mains voltage, and from the not naturally connected pin we are going to take one wire and we are going to connect with the sockets. So in the socket the connection is very simple. We have the live and the neutral, basically we have the live wire and the neutral wire. So in my case what I have did is, like I have connected the neutral wire directly from the main supply, and then the live wire I have taken through the relay. Okay, so in the middle pin of the relay I have given the live, and then from the naturally not connected pin I have taken the live and I have given to one of the sockets. This is how the simple the overall circuit is. And also here we will have the digital pins. So you have the input pins. So you have connect the NodeMCU with the input pin so that the NodeMCU can control the basically relay. Okay, so in our case we already have defined like D0, D1, D2 and then SO3. So these 4 pins I have connected with the, so I'm going to connect with the relay, and then also I am going to connect the VIN pin of the NodeMCU with the 5 volts I'm going to get from this, and also the ground I'm going to get from this. I'm going to connect to the ground pin of NodeMCU. Similarly, I'm going to connect a 5 volt pin to the VCC pin of the relay and a ground to the ground pin of the relay. Okay, so this is how overall the connection will be. So let me just connect it. So here I have the ground pin and the 5 volt pin. So I'll simply connect the 5 volt pin to the VCC VIN pin, 5 volt pin to the VIN pin, and the ground pin to the ground. Okay, and next I have this 4 pins here. So, and also as you can see the 5 volt also is connected with the relay, the 5 volt pin and one ground pin. So let me connect it, and these 4 pins are basically the relay input pins. So these 4 pins I'll simply connect with the D0, D1, D1, D2, D0, D1, D2 and the SO3, which is the 4th pin from on the other side. So this is how you are going to connect it. Okay, and you can simply put it here in this way. Okay, and now the whole basically the circuit is ready. So this is how simple the overall circuit is, and now you can simply connect this one. You can give power to this one, and then you have to connect the whole thing with your app. So now I'll show you how you can do that. So as you can see, I have given the power. Okay, and as you can see, the basically 220 volts to 5 volt converter is working. The relay also got the power, and the NodeMCU is also blinking. That means all the devices got the power. Very careful here because we are working with the mains voltage. Okay, now next thing is we have to connect the app. So here in my phone I'll show you. So you first need to download the Blynk app from Play Store. So this is how it will look like. Just give me a moment. So this is how the Blynk apps looks like. If you can see it, this is how that looks like. Okay, so you have to just click on it, and as you can see here, okay, so now I will just turn on my screen recorder and I'll show you there. Okay, so this is how the app will look. So initially in your case you will not gonna have any device. I already have created one project before, so that's why I have the Aquarium 1 I initially showed you. This is how it looks like. Now in your case it will be empty. What you have to do is you have to go to here and you have to go to add new device. Now the next thing is you have to click on the find devices nearby, and you click on start and continue, and now it will start searching for the device for the NodeMCU. It will take few seconds, and as you can see Blynk Spider test H&M1, you just click on that and it will be connected. So connection successful. Now it will take some time. And as you can see, now it is important, you have to give the Wi-Fi credential to which your NodeMCU or the whole system will get connected to. So in my case, this is my basically Wi-Fi setup. So this is how you have to give the network name, and also you have to give the password. Next you have to continue, and now it will take some time to get your NodeMCU connected to the Wi-Fi, and then it will connect to the server of the Blynk. So it will take some time. Now it has been connected, and now you can give it a name. So I'll just put sparkless test, and now you click on finish. And now as you can see, you have the sparkless test here. Now next thing is you have to create the mobile dashboard. Very simple. You just click on this button, and then you add a button here. In the similar way, you just add multiple buttons. 4 buttons will add. Now we will click each of the buttons. So first button here, you have to choose the data stream. So for the first one, I'll choose V0. And I will choose switch in the mode, not push, switch, and then I'll just click in the cross, and now it's V0. Similarly, I'll do for V1, and I'll do for V2. Sorry, I can make V1, V2, switch, and finally I'll make for V3 and switch. And that's it. We are done with the setup. Now our app is ready. Yes, this is how simple it is. Now you go back, and now you see we have the app ready. Now if I click on the switch one, now you can see that our relay 1 has been started. I turn it off, it has been stopped. Now click on, off, on, off, on, off. Now you can just turn all of them on, turn all of them off. And in this way it's going to work. Okay, now in a similar way you can actually control other devices. So if you don't want to connect all different like you want to just control a relay, you can use other devices, the similar process. So you just have a button, and then you can for example, it's a 5-volt device. You don't need a relay, you can simply connect it directly to your NodeMCU, and using similar things you can do it. Also, if you see here you can add multiple things. For example, if you go to add, you have the joystick, you have the zebra RGB. So basically this is what is like, it's basically the RGB. Okay, so if you add it, this is how it will go, and you can actually from here you can get different RGB colors. Similarly, you have LED, you have the value display. If you are getting any sensor value, analog value, you can use that one. You have tabs, and you have music player, and all different things, time input, and all different things, you have it. Okay, so in this way you can actually add multiple things and test with them. But overall, this is how it's going to work. Now basically we can simply just close the lid, and you can use it. Okay. So guys, I hope you have liked this video and you have learned a lot from this. Also, some other videos related to Blynk are coming. So for example, I'm also going to make a video where we are going to use a time input thing in Blynk. So basically you will be able to control turn on a device on a particular time of a day and turn it off. So you can schedule the turning on and turning off feature. So that thing we are going to make a video very soon. And also there are lot of projects we are working on. So stay tuned if you want to get the updates, and also if you want to see the future videos. Thank you. See you in the next video.